Welcome to our numerical analysis project presentation. We are from Group 7 and today we will be showcasing our interactive numerical root finder application. The main objective of this project is to develop a fully functional and user-friendly MATLAB GUI that solves non-linear equations using three core algorithms: the bisection, Newton, and second method. As you can see, we designed this app with a highly interactive multi-tab layout, separating the bisection, Newton, and second method into their own workspace. On each screen, users have a dedicated control panel on the left with intuitive input field, color-coded reset and calculate buttons, a live convergent axis plot on the right, and a comprehensive data table spanning the bottom to show every single iteration step clearly.
Looking at our MATLAB code, we first extract the user input for the function string, boundaries, and tolerance. To ensure an error-free, we build robust input validation. If the function is empty or if fx lower times fx upper more than equal to 0, the system safely triggers a UI alert pop-up to prevent crashes. Next, once validation passed, a while loop runs to compute the midpoint and error. Each step is stored inside the matrix. Finally, the matrix is pushed into UI table, and we use the plot function to draw the continuous curve and highlight the exact root on the UI axis. Now, we will demonstrate live compilation. Click the Run button, MATLAB compile the system and launch our graphical user interface. Let us run a live calculation using the function x to the power of 3 minus x minus 2 with bounds 1 and 2 and 0.001 tolerance. When we click calculate, the engine runs. Potential user immediately receives detailed row by row iteration breakdown in the table, and the convergence graph plots the target root visually. When click the reset function, it wipes the table data, clear the access, and reset the input field. This gives user clean workspace to start new analysis without needing to restart the application.
Next, I will demonstrate the Newton method. The Newton method uses derivative information, which allows it to converge faster compared to the bisection method. For this method, the user needs to enter the function, derivative, tolerance value, initial value, and maximum iteration. Now, we test the equation x squared minus 4. First, we enter the function x squared minus 4 and the derivative 2x. Then we set the tolerance equals to 0.001, the x0 equals to 1, and maximum iteration equals to 100. Next, we click the calculate button. The application generates the root, approximation, iteration table, and graph. As we can see, the result converges to approximately x equals to 2. We also implemented error handling. If the derivative becomes 0, the application will stop and display a warning message. Next, I will pass to the next member. Thank you.
Okay, I will continue with the second method demonstration. The second method is a numerical technique used to find the root of a function. Unlike the Newton method, it does not require the derivative of the function. Instead, it uses two initial approximation to estimate the next value and correctly converts to the root. In our application, the user entered a function together with two initial guesses x0 and x1. The program then performed interactive calculation using the second formula until the stopping criterion is met or the maximum number of iterations is reached. The results are displayed in a table and visualized on the graph. Now, I will demonstrate the second method. First, we need to input the function of fx, x squared minus 4, and initial value for x1, x0 is 1, x1 is 3, the tolerance 0.0001, for max iteration is 20. So, calculate. After clicking the calculate button, the application computes the root approximation automatically. As the result, the application successfully calculates the root of the equation. The graph illustrates where the function crosses the x-axis, while the iteration table shows how the approximation converts towards the root step by step. This allows users to observe the convergence behavior of the second method clearly.
In conclusion, our numerical root finder application successfully implements three numerical methods: bisection, Newton, and second. The application provides root approximation, convergence table, graphical visualization, and error handling through the interactive MATLAB app designer interface. This project demonstrates how numerical method can be applied effectively to solve nonlinear equations in a user-friendly environment. That's all from us. Thank you for your attention.